Hello everyone, my name is Tre'Shunda James and I am a second year grad student here at UTA. Today I'll be presenting my poster entitled Estimate of Interhemispheric Conductivity Differences Using SuperMag Electroject and Interplanetary Magnetic Field BZ. Before I get into the content of this study, I briefly want to clarify what I mean by SuperMag Electrojet and Interplanetary Magnetic Field BZ. So the SuperMag Electrojet, or SME, is an index used to measure the eastward and westward flowing current in Earth's auroral or polar region. And the IMF-BZ, or Interplanetary Magnetic Field BZ, is the southward component of the sun's magnetic field. So how are the two related? The two are related through a process known as magnetic reconnection, as shown here in the background and motivation section. So when the two are related through a process known as magnetic reconnection, which occurs when the solar wind from the sun or southward IMF meets the Earth's magnetic field. And that happens here in the shaded gray box. During this process, a voltage is created across the ionosphere, and this voltage is directly proportional to the Earth's magnetic field. And this voltage allows for a conducting ionosphere, which then can give rise to flowing currents in the ionosphere. However, the amount of currents in the ionosphere is asymmetric between the summer and the winter. So in this goal, we want to quantify this asymmetry. In doing so, we expect that greater illumination produces greater ionospheric conductivity and gives larger values of the current. We also expect that the aurora electrojects, as represented by SME, should be directly related to the amount of Birkeland currents. This relationship should be independent of conductivity, since it is only a question of a current closure. Previous studies have been done to qualify this relationship and quantify this relationship between summer and winter currents in the ionosphere. However, their work has been focused on using Birkeland currents. We look at the difference between the summer and winter ionospheric currents through a measure of SME, or the aurora electrojet. And so the aurora electrojet is the horizontal currents in the aurora region, and these currents can be measured using the SuperMag Electroject. And the Birkeland currents are the currents that flow along the magnetic field lines. As you can see here in the picture, the Birkeland currents and the eastward and westward electrojet are actually connected to one another. And in this case, the eastward and westward electrojet actually closes the Birkeland currents. So in investigating this asymmetry, here are our results as shown. So we see here for summer and winter, plotting the SME versus the electric field. We see that in the summer, just by visual inspection, in the summer, the SME is higher than in the winter. We also investigated this asymmetry using the Birkeland current, as previous studies have done before as well. And we see that in the summer, by visual inspection again, that current is higher than in the winter. So the ratio between summer and winter using the SME current we found to be approximately 1.5, and using the Birkeland current we found this ratio to be approximately 1.6. Additionally, we investigated the correlation between SME and Birkeland current for both summer and winter. So on the left we have the winter correlation between the two, and the summer correlation between the two is shown on the right. And here you can see that this relationship is linear in both scenarios. So it is linear in the winter as well as in the summer. And this brings us to a conclusion. In conclusion, we find that both the Birkeland currents and SME values are higher than the summer solstice as compared to the winter solstice. This relationship between SME and Birkeland currents is essentially the same across seasons, and that is consistent with the idea that the amount of electrojet is proportional to the amount of Birkeland current. And this relationship is independent of conductivity, as it should be, because of current closure. And with that being said, I would like to acknowledge those listed below for their support as well as for the data used in this study. Thank you.